I'm Dr. Roji, and in this session, we'll do a problem on clamper. This is a clamper circuit. The input to the clamper is a square waveform. The high positive voltage is 10 volts and the negative voltage is minus 20 volts. Right? So here, to start the analysis, we'll assume that the operation is in the time interval T1 to T2. Okay? From T1 to T2. We are in this session. So when the operation is between T1 to T2, what is the input wave? Input wave is at minus 20 volts. So Vin is equal to minus 20 volts. Is that right? So it will be a minus here, a plus here, and Vin will be 20 volts. Okay. So what will be the state of the diode D? The diode, when you consider the diode, this negative voltage is coming to the cathode. And the anode is given by a positive potential of 5 volts. So this diode will start conducting when the cathode voltage is less than 5 volts. Am I right? But we are giving a huge negative voltage of 20 volts. So the diode will definitely be on since it is forward biased. Okay. Since the diode is forward biased. Okay. So when you take the loop equation of the inner loop, KVL of the inner loop. Okay. Yeah. So what will you see here? V input is 20 volts, right? And we have a capacitance here. We will mark the potential as minus to plus. That will be VC1. And you have a potential of 5 volts here. The voltage across the diode D is neglected when compared with all these things. Right? So Vin is what? 20 volts now, right? So I can write it as minus 20 volts plus Vc minus 5 volt is equal to 0. Therefore, what is Vc? Vc is equal to 25 volts. Okay? So in the place of Vc, I can write Vc is equal to 25 volts. So this happens when the input voltage is at minus 20 volts. Now what is the output voltage? What is the output voltage? The output voltage is the resistance appears directly across this branch. Right? Here you have a diode and a voltage supply. The diode, when the diode is on, it has a very small voltage across it of 0.6 volts or something like that. And this is 5 volts. Is that clear? I neglect the diode drop in comparison with 5 volts. So the voltage across the output VO will be approximately equal to 5 volts. Why did I take it as an approximation? Since drop across diode is neglected. Okay. So it is approximately equal to 5 volts. So how will I represent that in my diagram? I will draw the waveform here. So from T1 to T2, the output voltage is going to be small. It will be at 5 volts. Okay. It will be at 5 volts. Now I'll come to the next part from T2 to T3. Right? Operation is from T2 to T3. Operation at V input is equal to T2 to T3, right? So T2 to T3, what do we have? From T2 to T3, Vin is at 10 volts, right? So from T2 to T3, Vin is 10 volts, okay? Vin is 10 volt. And what will happen to the diode D? This input voltage is plus 10 volts. That is connected across the cathode, which makes the diode to be, and the anode voltage is at 5 volts. The diode is now off. So it acts as an open circuit. So as we did before, what can we do? We can remove the diode from our figure. The diode is removed, or the diode is assumed to be an open circuit. Is that right? So this branch is totally cut off from the circuit. So we have to write the KVL of the outer loop now. KVL of the outer loop is what we want now, right? So when I write the KVL of the outer loop, how will it be? The current from this 10 volts will flow here, here, and it will flow here. Is that clear? So how will I write the equation? V in is 10 volts, right? Sorry, I had left out the capacitor by mistake. I have a capacitor here which is minus plus, which has a voltage of 25 volts. So V in is 10. You have it. This is minus to plus. 25 volts is again minus to plus. And when you come here, VO, normally we take this plus to minus. So what's the equation? 10 plus 25 minus VO is equal to 0. So what is VO? VO will be equal to 35 volts. So when the operation is between T2 and T3, what will be my output voltage? Output voltage will be around 35 volts. Okay. I'll take this as 35 volts. So this is how you analyze a clamper. You take the various operating conditions of the diode, and based on that you see how the capacitor charges or discharges, and then everything can be drawn on the input-output curve. So this will help you to understand the clamper more. With this, I'll come to the end of the session. We'll meet with another session in the next class. Thank you.